Is that Dylan Math 2?
Yep.
No,
No.
I think it's probably this other one here.
Yeah.
Okay.
Let's try that.
Did
Yep.
you scan these with a scanner, or did you take a picture with a smartphone?
I think my mom scanned them.
Scanned them?
Yeah.
Probably it would be easier and more readable if she took a picture with her smartphone.
Okay.
I've discovered that. I used to scan everything into my computer, and it took a lot longer and wasn't as clear as when I finally got a smartphone. My smartphone only has like a 5-megapixel camera on it. But the beauty of the smartphone is you can send it direct to my email address. You don't have to take it through your computer. So, whereas when she scans it, she's going to create a file on your computer, and then you have to send me that file by email. It's actually an easier process doing it from a phone.
Okay.
So you might suggest that to her. And it looks like the quality here is just barely readable when it's
Do you want me to read?
scanned. No, I can make it out. It's no big deal. But for the future, it's probably going to come out a lot better if she takes a picture with her smartphone.
Okay. All right.
Let's look at 5 here. Boy, everybody's in probability and statistics. I always find it interesting that whether you're in algebra, geometry, or pre-calculus, everybody gets to statistics and probability at about the same time. They just have different degrees of difficulty.
Yeah.
Okay. So if you roll one standard 6-sided die 174 times, how many times do you expect to roll a 5?
Okay. Wouldn't you just do 174 divided by, well, no.
Yeah?
174 divided by 5?
Not by 5. How many faces are on
divided by
the die?
6.
Divided by 6. Because a 5 is just one of those faces.
Yeah.
One of those 6 faces has a 5 on it. So the odds of it coming up are going to be 1 out of 6. So if something is 1 out of 6 and you do it 174 times, you're going to divide by 6.
I got 29.
So we would expect 29 5s. In other words, if 1 out of... You get why we're dividing by 6?
Uh-huh.
We're really multiplying by 1/6 is what we're doing. Makes more sense that way. Because we know that the odds of getting a 5 are... can't get my eraser. The odds of getting a 5 are 1 out of 6. So we're going to multiply the number of rolls by the odds of getting a 5.
Okay.
And that's why we end up dividing by it.
All right.
Okay.
Cool.
Number 6.
Yeah.
We spun the spinner 120 times, is that right?
Yep.
Okay, and they got these results. Now, they don't tell us any angles here. So we have no way of calculating what the probability of a green, a red, a blue, or a yellow would be, because we don't know whether that's 90 degrees part of the circle or what. They haven't told us.
Yeah.
So we use the experimental method where we count up how many greens we got out of 120 rolls, and since we got 40 greens, it should be, what should be the odds of a green coming up?
Huh.
Based on 120 rolls, and we got 40 greens. So that would indicate that green comes up what % of the time? What fraction of the time?
40 over 120.
Which is 1 over 3.
Or 1 over 3, yeah.
Okay, so that would be the experimental probability of a green coming up. That might not be the true probability. In other words, if we spun this thing 1,000,000 times, we might get more or less than 1 out of 3. The whole thing
Yeah.
about experimental probabilities is they're not going to be exact, but they're going
No.
to give you an idea. So
Yeah.
from this, from the fact that green is 1 out of 3, we could make the leap that this green part of the circle is 1/3 of the circle.
Mhm.
Because it comes up 1 out of 3 times.
Okay.
So what about red?
Okay, so red would be 44 out of 120.
Okay. You have your calculator. Can you simplify that? Let's see, that's
Yeah.
22 60ths, 11 30ths. So
11, yeah, I got 11.
11 out of 30.
Okay,
So
for which one?
probability, you need to
Red.
convert that to a number. Just
So
like
red, yeah.
we had to convert 1/3 to 33 and a third percent probability.
Okay, so red would be 11/30ths.
Uh-huh.
Okay.
So what is that decimal?
Here, let me see here. 11. Calculator's messing up. Okay, so 11 divided by 30. I got 0.36.
Okay. So we could either answer 0.36 or 36%
Yeah.
for the probability of red. Do you know whether they want their answers in percent or decimal? Doesn't really matter. They're the same thing. Saying 0.36 is the same as saying 36%.
Okay.
Okay.
Do they want it in
I don't.
decimal?
I do not know. Here's look at the next part of it, and they give you the theoretical probabilities. They're in decimals. So let's put these in decimals.
Okay, so for the green, would that be 33%?
Be 0.33.
Okay, so 0.33.
Mm-hmm.
And
For
then...
the red, it would be 0.36.
Okay.
For the blue, what is it?
So blue, 15 out of 120.
Go ahead and give me a decimal on that.
Okay. I got 0.125.
So what's the decimal?
12.5.
No.
I mean,
Remember that the probabilities have to all add up to 1. Look at their theoretical probabilities. We got 0.3, 0.1, 0.3, and 0.3. Add those 4 numbers, you get 1.
Okay.
In other words, when we spin this spinner, it has to land on something. 100% of the time, it's going to land on one of those 4 colors. So the odds, the probabilities of them have to add to 1. So if red, we figured out red was 30.36. We figured out green was 0.33. So it wouldn't make sense for blue to be 1.25 or 12.5. It's got to be 0.125.
Yeah.
Okay, how about yellow?
Is that blue?
Yellow, no,
Yeah.
blue is 0.125.
Yeah, that's what I got. Okay, so...
The last one is yellow.
Okay.
Now, the only thing I know for sure about yellow is that whatever it is, these 3 numbers have to add to 1.
Okay. And I got 0.175.
Notice they do add to 1 because these add to 0.3.
Okay.
All 4 of them add to 1.
Cool.
Okay. So those were the experimental probabilities based on our trials. We only spun it 120 times.
Yeah.
So Mrs. Smith determined the theoretical probability was these.
Okay.
Okay, and how she determined that was she probably measured this angle.
Yeah.
And that angle is 3/10 of a full circle.
Yeah.
So that's why the theoretical probability was 3/10.
Okay.
And the blue was 1/10 of a full circle.
Yeah.
Okay, so that must be a 36-degree angle there.
Uh-huh.
Whereas this would be a 108-degree angle, 3 times that.
Yeah.
You're saying the green and the yellow have the same theoretical probabilities, which means that that degree angle of the sector is the same for green, for red, and for yellow.
Okay.
They're each 108 degrees.
Okay.
They're 3 times 36.
Yeah.
So if you look at the probability of yellow in part A and part B, how do they compare? Well, would we come up for yellow? 0.175 compared to 0.3. Is there a difference? Explain. There is a difference. The difference is subtract those two numbers.
Yeah.
The difference is 0.125.
So I'll just say the difference is 1.25 or 0.125.
0.125.
Yeah.
Okay. And explain why. Well, because one is theoretical and the other is experimental. Experimental rarely comes out exactly the same as theoretical.
Yeah. So one is experimental.
And one's theoretical. Another way to figure out this, or to look at this, is let's flip a coin. What's the theoretical probability of heads?
1/2.
0.5. Theoretical probability of tails? 0.5.
1/2. Or
They
0.5. Yeah.
add to 1 because it has to fall on either heads or tails. Well, let's say we flipped a penny 100 times and we got 60 heads and 40 tails.
Mm-hmm.
Our experimental probability for heads would then be 0.6. Our experimental probability for tails would be 0.4.
0.4.
So the difference would be 0.1 for each one. And why, I hate that question, but
Yeah.
it's a dumb question. Why is there a difference? The answer is because one is experimental, one is theoretical. There's no other good answer.
No.
That's why it's a dumb question. But,
Okay, yeah.
okay, so 7.
All right.
Works at the local deli making sandwiches. The choices for bread, meat, and cheese are shown in that table. Make an organized list, table, or tree diagram to show all possible combinations of sandwiches. And,
It's kind of a bland sandwich.
well, I don't know. Not so bad. That's a pretty good selection. Well, you're right. If it just got cheese,
sauce.
That's a bland sandwich. Cheese.
Yeah.
I think I have this exact one in my book. Pretty sure I do.
Oh.
Let me just open it to that page. By exact, I mean exact. Ham, turkey, roast beef. See if you can see this.
Yeah.
See the tree diagram? Still enough that you can read the words.
Oh, yeah. I can't see the words, but I see the tree diagram.
Mine only has 3 choices of bread. Mine, the choices of bread are wheat, white, or rye, whereas yours, the choices of bread, there's 5 choices of bread.
Oh, okay.
There's 4 choices of meat and 3 choices of cheese. So
yeah.
Let's just do a quick tree diagram to make sure. Help me out here. How am I going to draw this tree diagram?
Oh, okay. So Italian first.
Okay.
So
We'll use I.
Yeah.
And
then wheat.
And then rye. And then white.
Mm-hmm.
And then flatbread. So that's the first choice we have to make, is what kind of bread we want.
Yeah.
What comes off of here?
Off of Italian.
Uh-huh.
Um,
In other words, we're going to
beef.
start our first branch.
Okay, so beef, pastrami, turkey, and ham.
So you need 5,
Yeah.
and this is beef, pastrami, turkey, and ham. I only needed 4, actually.
Yeah.
And then off of each of those, I get,
3.
So, and that's American, Swiss, mozzarella. And then I would have these 3 branches coming off of every one of these
Okay.
and every one of those.
Yeah.
So when I'm done, it's going to look like that.
Okay.
Make an organized list, table, or tree diagram to show all possible combinations of sandwiches. Okay, so let's just go through how we're going to do this. One possible sandwich is Italian with, what is that? Beef?
Beef, yeah.
So Italian with beef and American cheese. What's the second possibility if I'm starting from the top going down?
Let's see here. So next one would be pastrami with Swiss.
Well, let's maintain an order. It's Italian bread, pastrami with American.
Oh, yeah.
In fact, let's do this. Let's start from the right side. In other words, let's do all the IBs.
Okay.
So we won't lose our place. We're going to do IBS and IBM. IBM. So this is an Italian bread beef with American cheese, Italian bread beef with Swiss cheese, Italian bread beef with mozzarella. Now we got Italian bread pastrami. So I'm going to make a list. I'm going to have a lot in this list because I've got 5 times 4 times 3, which is 60. So there's going to be 60 possible sandwiches we can make. So I'm not going to make the whole list here. We'd take all of our time. But let's make the next 3 choices. What would they be?
Okay, so let me just write this down here. Okay, so the next one would be, let's see here, wheat.
No, let's finish all of the Italians.
Yeah, that's right. I'm sorry. Okay.
Because if you jump around, the problem is you never know which ones you've listed.
Yeah.
So you kind of want to list from the top down.
Yeah.
So we've done all the IBs. Now let's do all the IPs.
Okay, so Italian, pastrami, American, IPA. That's a beer.
Oh, is it? Yeah.
Yeah, my dad gets that. So IPA, IPS, what else? And then IPM.
IPM. In other words, the best way to make your table is just to do all of the I's and all of the B's, and then do all of the I's, all of the P's, which we've just done. Now we're going to do all of the I's and all of the T's.
Okay.
So T-A, I-T-S, and I-T-M. Now we're going to do all of the I's and the H's. So I-H-A, I-H-S, and I-H-M. So we've just done all of the Italians possible. There's no other way to use Italian bread and make a sandwich.
Okay.
We've gone through all of these combinations and each of those for each of these.
Okay.
So we should have had 12, and we do. Top, 6 on bottom. In fact, we're going to have 12 Italian sandwiches, 12 wheat, 12 rye, 5 times 12 is 60. We knew we could make 60. So now we
Oh,
do
wow,
the
cool.
same thing with wheat.
Okay.
First one would be, I'm not going to do it all, but I'll do the first one. Wheat BA, wheat BS, wheat BM, wheat pastrami A, so forth and so on, all the way down to flatbread.
Yeah.
Now, the answer to this is quite involved because you're going to have to write out 60 things. And
Wow.
it looks like you can either do it as a giant tree diagram
Or lists.
or a list like I've started here.
Yeah.
Your list is going to end up with 60 things in it.
Wow. Okay.
12 for each. Just
Yeah.
methodically go through all 12 of them. And whether you make a tree diagram or a list, you're still going to have to do 60 things. I mean,
Yeah.
even if I made a tree diagram, a proper one, I don't have enough room on here to make it. But if I did, I would have 60 branches in total.
Wow. Okay.
Okay?
Cool. All right.
All right. So
Let's see.
let's go to the
All
next
right.
page. That must be Dylan 2.
Yeah. This is actually the last page. Well, all right. So I already did the histogram.
Okay, let's look at 8. Let's just go from the top down.
Okay.
Well, let's look at that second question. I didn't get this on the previous page.
Yeah.
If all choices are equally likely, what's the probability that the next something is a sandwich?
Yeah, so next order is a sandwich on white or rye bread. Justify your probability by explaining how it was determined.
Okay. What's the probability that it's going to be white or rye?
2 out of 60?
How many breads do we have?
5.
White or rye are 2 out of those 5.
Oh, 2/5.
Mm-hmm.
Okay. Oh, so it'd be 2/5 for the probability.
Right. If somebody orders a random sandwich,
Yeah.
2 out of 5 of them are going to have white or rye bread.
Okay.
In other words, 1 out of 5 would have white, 1 out of 5 would have Italian. So to have 2 of them, it'd be 2 out of 5.
Yeah. Okay.
Justify your probability by explaining how it was determined. All right.
I'm just saying, like, because 2 sandwiches are white and...
Probability is the number of likely events divided by the number of possible events.
Yeah.
So the number of successful events here is 2. It can either be white or it can be rye.
Yeah.
The number of possible events is 5. There's 5 choices of the kind of bread it can be. So it's 2 over 5 based on the definition of probability. Remember, probability is defined as the number of successful events divided by the number of possible events.
Okay.
And in this case, the number of successful events is 2, white or rye. The number of possible events is 5. We don't care about all the other ingredients of the sandwich at this point.
No.
We just know that there's only 5 types of bread, and they've asked about 2 of them. It's got to be 2/5.
Okay.
We're not going to look at our tree diagram to determine that. We're going to look at just the first number of possible types of bread.
Okay.
Okay.
All right.
Okay. Number 8. Show the following data in a circle graph.
Okay. I'm going to need a protractor.
Well, you can do that on your own. Let's you and I talk about the conceptual way we would do it.
Yeah.
So how big of a slice is September going to be?
So 2/18.
Right.
All right.
So that means 1/9.
Oh, yeah, thanks. All right. So yeah, 1/8.
1/9. 2/18 is 1/9. So
Yeah.
this slice for September has to be what part of the circle?
1/9 of the circle.
Okay. How many degrees are in the circle?
So you would do 1/9 times x over 360?
No, just times
Or
360.
360. Okay.
In other words, that's 40. So this has to be 40 degrees. So yes, you would need a protractor, but you're going to make that angle 40 degrees.
Oh, okay.
Okay. Now let's look at October.
So October would be 1/18.
Okay, times 360.
Yep.
So what's this angle going to be?
Um,
Notice also that October is exactly half of September. What does this angle have to be?
oh, it's exactly half. So 20, right?
Right.
Okay.
Okay, now let's do November. November is 7. That's almost half.
Yeah, so 7/18
November. 7
times,
eighteenths times 360 gives us 140.
yeah.
This would be 140 degrees.
Okay.
December is 4.
So for December, would it be 1/3 times 360?
Or twice September.
Yeah.
December is twice September. September was 40 degrees. December has to be 80 degrees.
Yeah.
In other words, there's a shortcut. Once you've figured out one of them, you don't have to do 4/18 times 360 anymore. You
Okay.
know that this angle has to be twice that angle.
Okay.
So it's got to be 80 degrees, and January has to also be 80 degrees. So if we add up all these degrees, we should get 360.
Okay. So,
And we do. This is 200. That's 160.
so September is 40 degrees.
Right.
And then October is 20 degrees.
Mm-hmm.
November is 140 degrees.
Right.
And then December is, let me see here. What is December? 80 degrees.
Right.
And then 80 degrees also.
Right.
Okay.
Okay. And we don't include the other 7 months of the year because they're not included in this table. In other words, this table only does September through January, and this whole circle has to include all of these 18 absences.
Okay.
Okay. And we could label these with numbers also. September would be 2, October would be 1, November 7, this is 4, and this is 4. Okay?
Okay.
All right. All right, let's look at number 9.
Alright. What is the probability of randomly dealing 2 kings from a standard 52 card deck? There are 4 kings total in the deck.
What's the odds of pulling a king on the first?
452.
Now, for us to pull 2 kings from the deck, we have to get a king on the first draw, and we have to get a king on the second draw.
Yeah. So you multiply that by 2?
No.
No, wait, no.
After we've pulled a king, now what's the deck got left? How many kings?
If you pull 2?
No. After we've
Or
pulled
4.
the first king, which is a necessary action.
51.
And how many kings are left?
3.
So it's 4/52 times 3/51.
Oh, okay.
Okay. because
Okay.
obviously you have to pull a king on your first one. That's 4 over 52. But now we have a 51 card deck,
Yeah.
and they didn't put the first king back in and let you redraw.
Yeah.
They're going to let you draw 2 cards from the deck without
Okay.
replacement. So when you're not replacing, it's 4 over 52 times 3 over 51.
Okay. And you
If they drew the first king and put the card back in the deck and shuffled and drew a second king, well, then that would be 4 over 52 times 4 over 52.
Yeah.
So there's a difference here whether you put the king back in the deck or not. If you're playing No Limit Hold'em and you get dealt 2 cards, well, the first card you get dealt doesn't get put back in the deck when you get dealt your second card. So to be dealt 2 kings in No Limit Hold'em would be 452 by 351.
Okay. Cool.
And that's actually 1 over 13 times 1 over 17.
Oh, so that would be the answer?
Yeah.
Oh, okay. So
1 over whatever 13 times 17 is.
okay. So do you just like
I just simplified.
I'm kind of
450,
Oh yeah, okay.
450 seconds was 1 over 13. 350 first was 1 over 7.
Okay.
Okay.
I get it now. Okay.
13 times 17 is 51 plus 170.
221.
So there's a 1 out of a 221 chance that you'll get dealt 2 kings when you sit down and you play No Limit Hold'em. Do you even know what No Limit Hold'em is? You ever watched it on TV or anything?
I haven't, no.
Okay. All right.
Yeah.
I'll just know whether to use that as an example or not.
Okay.
If you haven't, I won't. Okay, and then you've done this one.
Yep.
And that one looks correct.
Cool.
I
think
think.
we're...
Here, let me just... Okay. Yeah, this could be a little higher here to go with the 2.
Oh, yeah. Yeah.
You understand the problem. I can see that. So.
Yeah.
Okay.
Cool. All
So
right.
that's all of the stuff you sent me.
Yeah, that's it.
That's it?
Perfect. Yeah,
Okay.
that's it.
You don't have any other questions or anything?
I don't think so, no.
All right. Well,
Okay.
we'll end it right here.
All right. Thank you.
Okay. Before you go, let me just check. Dylan, let's see. If an appointment opens up tomorrow, your dad said you wanted it.
Yeah.
Do you have additional stuff to cover?
Tomorrow, actually, I think we're just going to be correcting, like, the mistakes we made on, or correcting mistakes on the unit packet.
Okay.
I don't think there are any mistakes, so.
Okay. So you don't
Yeah.
really, you're not in desperate need for another session. You have a test on Thursday, I think?
Uh-huh.
Okay.
Yeah, I doubt we'll have any other homework tomorrow.
Okay. All right.
But we'll call you if we need you for if you
Well,
have an opening.
I will text you or email you or something if an opening pops up, and then you can tell me whether you want it or not. If you don't want it, that's fine. I got no problem.
Okay.
But if you need an appointment, when you get done with school, go ahead and send me an email or a text, and then I'll know to let you know if an appointment opens. Because the only ones I've got are from 3:30 on, and I'm full now. But if one of these cancels, then I could fit you in. So
Cool.
let me know if you want an appointment or not, and if so, I can get you in there.
Okay, cool. Sounds good.
Okay.
All right. Thank you.
Have a good evening, and I'll talk to you maybe tomorrow. Maybe. Oh, let's see. I guess before I let you go, let me just check next week. See if your dad's made anything. Now, next week you're on spring break, right?
Yep. Mhm.
Okay, so you don't have anything that week.
No.
He hasn't made any other appointments, so
Yeah.
I'll let him make whatever appointments he needs. And
Okay, sounds good.
I am going to be out of town on the 11th through the 15th of April.
Okay, cool.
Got to go to a wedding in
Cool.
Arizona.
Well, that'll be fun.
Yeah, it should be.
Yeah.
Certainly
Cool.
more fun than the funeral I had to go to last week. So.
Ah, I'm sorry.
Yeah, well, it turns out the girl that's getting married is the sister of the guy who died. So.
I'm so sorry.
I'll see all that family again at the wedding, which will be nice, actually.
That is nice. I'm sorry about that.
Thank you.
Yeah.
All right, Dylan.
Yeah.
Have
All
a
right.
good one. I'll just talk to you next
Well,
time.